and welcome to another day in programming land. We're gonna keep on implementing some stuff here. During the last episode, we created the tone mapping. This is the Reinhardt version. And we'll do like this. Yeah, so let's create a include file here. Share.hl. Let's exclude this from the project and clean it up. And then let's add this tone map. And we don't need to include it for this one. Okay, let's do let's do a combined let's create a Bloom GC Bloom tone map shader, and that will actually stand for gamma correction. Let's create most of this stuff here. Let's see, saturate, we don't want that. And we want to include shared.hl. So we do the color correction here. Hello, buddy. How are you doing? And let's see. Let's see. DX12 PostFX pipeline. Let's just copy it. Type gamma bloom tone map tone line. So let's create a new PostFX pipeline. Also, one, and let's do a two. Oh, I copied that one. Let's see. Okay, let's do a implementation where we only use one. What do you call it? Descriptor table here. And let's do a implementation where we do basically the same, but we use two descriptor tables. One thing I want to add is also let's bind a constant buffer as well to our PostFX pipeline stuff. Since we want to be able to actually create a set of data structures that actually are able to be filled with data. I mean, maybe we want separate ones. Yeah, I'm not sure actually we want this one to reference anything in particular because we wouldn't give the impression that pass through, yeah, uses anything. Let's do combine gamma correction, bloom, and tone mapping to sRGB colors. Whoops. Okay. Let's create the input parameters here. Let's create our pipeline reference. Let's see. And we have our PostFX okay. Let's initialize a constant buffer here. on the standard alignment. On the, let's do the default heap. We're not going to change this a lot. Common. And this can actually attach constant buffer it here. Right. There we go. And let's remember to add that to our, what do you call it? There we go. Constant buffer detach. There we go. So we create a constant buffer with some information. We will store our what do you call it? Kernel information in this for the Bloom. So does this compile, or do we have problems? No, it does just compile. Okay, that's pretty good. Okay, inside the root signature then, we want for PostFX let's see, let's just copy a constant buffer thingy. Let's see, 2, 2, 2, 2, 2. Here we go. Constant buffer information, or rather, effects data. Let's do a struct effect data test. Effect data. All right, this should be fine. Yeah. Let's see, and let's pass this in. Okay, and inside this, right now this won't work. Let's do DX. set graphics constant buffer view. Let's see, ppipe constant buffer. We can also just do this like right. There we go. And we're doing our pass through the Reinhardt tone mapping as a proof of concept. Let's just check that we actually do. Yeah. Okay. Also, we want a linear sampler. Also, I think we want a clank sampler in order to not let's see. This is for the shadow map. What's up with the fire emoji, buddy? I mean, we could disable the wrap stuff. I don't know. Okay, we'll have to restructure our stuff here, I think. Or we could just keep it, but I don't know. I actually want to. Yeah, true, true. It's always nice when things work. Okay. Should we really rewrite our stuff? Okay. I guess we should. Okay, let's do it. D3D12 filter min magnify mip point. Let's do also update this. for now at least. And let's do clamp point sampling clamp mode. Then I don't think this should be comparison. Yeah, right now. Yeah, we overlap. So wrap is fine. Okay. Maybe we want different spaces for points, or yeah, let's just try that, I guess. So if we do shader register, but register space 1 here, basic point, okay, and then yeah, okay, this should get rid of the overlap, but right now we won't be sampling correctly. Yeah. Yeah, and then we need to fix this. Five. Let's just do something like const expression. It's an int samplers. Uh, uh, let's see. So huh. Okay. When we do this polygon here, point ramp. This is the shader T1. Will this oh, whoops. Oh, there we go. Space 1, right? Yeah, there we go. So we have the next problem in our skybox. Okay. And then transparent polygons. At least we have shader compilation errors before we even boot the application. Space 1. And we have the emission pipeline. And then we have the new pixel shader that we just created. Let's see. It's that one. Sampler point ref. Clamp here. And in our root signature point rep. So it's register 1, register space 1. Ah, whoops. There we go. Uh, could I even pass in a series of base shader register? Okay, is it related to the oh yeah, of course I need to increase the... What? Am I not? Isn't that the problem? Is it this one? Oh, it's this one. Space 1, right? There we go. I forgot we had that one. Okay. Next, we want to create an actual additional texture that we can sample from. So we need to do some modification to our pipeline state creation function here, particularly this function here. So instead of doing a bool here for the use render target, we will actually do an int, and let's do this true will still evaluate to 1, I think. Let's see if use render target is above 1, then we do PSO disk num render target, use a render target, and then for unsigned int I list and use render target and I++, and let's set PSO description RTV formats I, yeah, equal to this. So this should still work, I think. Yep. But we're allowed to make a pipeline with several rendered outputs. So for our polygon pipeline, let's actually create 2 render targets. And now inside our polygon pixel shader here, we can actually create a pixel shader output. And let's do float for RGB, or rather color SV target 0, and a float for brightness SV target 1, and let's return a pixel shader output here. And let's do a output dot color equals lid color, And let's return the output here. And then right now, let's just do a output brightness here of float 1, 1, 1, 1. And let's see if we have crashes. We might have. No, we don't. Because we haven't bound a render target, nothing will happen. So everything works so far. And let's do the exact same thing as this one. So a pipeline should be allowed to well, I guess yeah, I don't know. Let's just do this for now. Resource SRV2, or maybe just an array here of 2. Zero. Here we go. Let's see. Whoops. Okay, let's clean up this. Whoops. There we go. Where did we go? Okay. So we're allowed to create at least 2 SRVs here. This is not any longer a test area. Render target 1. Let's see. Render target 2. And let's actually just duplicate this code here. Let's see. Seen as texture. let's see, brightness, scene, brightness, texture, and the third custom thingy here. And increase this. So the fourth one should be mapped up here. Render target 2. And our descriptor heap up here. Custom RTVs. Let's increase this to 3. Let's see if everything runs and compiles. Yeah, so far no errors. Okay. And let's see. Let's do RTV handles. And this is supposed to be for one render target. And let's add a clear color for this one as well. So this should hopefully run. Yeah, but we do have an error somewhere. Oh yeah, okay. Maybe I don't transition the resource here. No, I don't. There we go. Okay, so let's try actually running this in RenderDoc. And did we actually get our, I think we got our shaders updated. Anyway, let's see. So we have a scene as texture and scene as brightness texture. So let's see, we have our scene right here. And inside our brightness texture here, we should have all white. Yeah, all geometry is white. At least for polygons. Okay. That's pretty good. So now we can modify our shader here. And let's do a bloom uh, uh, brightness sampling here. Um, let's hard code it for now. We could add a value to it, but I guess we don't care for now. Let me just check some stuff here. Okay. So if we compute the brightness by dotting the lid color .rgb with a float 3 with these components here, we will get the grayscale version and the overall brightness of the color spectrum here. So if the brightness is larger than some kind of like, let's do a, can I do a const expression? No, I can't. Const float bloom threshold. Could be part of the render pass struct or pass data struct. Is it called pass data struct? Okay, so if we're over the brightness threshold, we return the color, otherwise we return black. Float for 0, 0, 0, 1. Okay. So let's see, let me clean up the shaders for render doc. I have to do that because it doesn't copy over updated shaders yet. I should add that to a to-do, make copy on build script, force update of newer files. Okay, anyway, this should end up building the shaders in the directory. And so let's see. If we grab our scene as texture and our scene brightness texture, okay, we're actually not getting a lot of result here. Which would mean that we have no brightness over the specified threshold. We could try lowering the threshold quite a bit. I'm just updating some stuff here so that our build script, when it runs, actually does something. Okay. Let's see, did this change anything? Scene as brightness texture. Yeah, we start seeing some brightness here. I'm not sure why we see anything right there. Let's compare to the scene as texture. Oh, It's the dude. Yeah, so we do actually render something to our texture. It's just that the material light interaction tower material, for instance, let's do something like this. And let's do render doc here. And resource inspector, scene, brightness, texture. Oh. Well, we're not rendering that one. So yeah, only the player thing is bright enough. So if we increase the lights in the scene here, I think we would get a different result. Yeah, as you can see here. Yeah, I'm definitely not very fond of this kind of like interaction. Yeah, basically this is the most brightness that we have in the scene, and it's even over. Yeah, it's somewhat bright. Yeah, so I guess the we could force the we could bind the actual texture to okay, let's not use this, so let me just clean that up. Right now we don't output anything to our what do you call it? What do you call it? Brightness texture, I think. But at least we now have the ability to do it. Yeah. So that's great. We don't want any of our current objects other than the tower to actually be shiny. So if we kind of like, when we do this pass here, let's see, why is it called extra? Yeah, anyway. If we bind the render target here to our we could parameterize this. So we specify the render target, but if we kind of like if we bind the temporary binding of the brightness output as and let's do the depth stencil view as well, because otherwise we will have trouble. So if we do like this, and we set it back, there we go. Yeah, right now, as you can see, we're writing the brightness values to something else. I might have to change the texture though. And as you can see, we actually do the emissive material into our scene brightness here. Let's do maybe a 100 range. Oh, we can even, it's pretty bright. It's pretty bright. It's way too bright. Definitely. But at least it works. Okay, so that's at least a possible way to do it. That we let emissive materials render to a separate kind of like pipeline. Yeah, so that's the least possible. Also, if the emissive pipeline here is bound anyway, let's see if we even need this. If we just Change the emissive pipeline emission mesh vertex shader. Can I do that? No, because we're not allowed to use two render targets. Yeah, we could so we could simply force that pipeline to have a write to a no, not in here. In here, we could let the emissive pipeline have two render targets. And it will just write directly. I guess that's better. Yeah, right now we're trying to do kind of like some stuff here. This should, in fact, let's see. Let me just update. Run it in RenderDoc. So this should work the same way. If we look into our scene buffer, our brightness texture, we still get our brightness values here. So that's one way to do it. Simply let the emissive pipeline write directly to the brightness RTV. Oh, actually, overdo it, that's why. Anyway, let's see. Yeah, so if we look into the texture itself, we have our heat palette. We also have the color palette here. I don't know if we actually want a I don't know. I don't know. Anyway, let's add the whole sRGB color correction. Let's do that. So let's do a float linear to sRGB. And let's take a float 3 color and a float gamma. And let's return power, the absolute value of the color, uplifted to the power of the gamma value here. Gamma. There we go. And let's we could do a const float exposure, const float gamma. And let's do float sRGB, SDR color, oh, right, gamma, and let's do the sRGB here. Now we should have interwebs gamma corrected colors. Okay. It looks weird. It looks very weird. Maybe we want to adjust the gamma. Yeah. Okay. Okay. And we're doing pretty good here. So this is our color correction stuff. Since we're applying bloom here, let's see in our renderer when we do pass 2, which we do, right? We use the 2 pass. We actually have created a brightness texture, so this shouldn't bother us anymore. Oh, it's not initialized? Or what? Oh, it's not possible to use this as shader resource, right? Yeah, render target. So we need to do the same thing for this. Transition SRVs. And let's do the same thing down here. There we go. Okay, so we can actually start creating some bloom effect. I'm not sure I want blending actually on the emission thingy anymore, since it's, yeah, let's disable the render, or rather the blend state of the emission pipeline here. So right now we're using blending like this, but it's more expensive, and I think we don't need to use blending. So after the render targets, we have the blend mode, which will be 0 here, and this will make it a bit faster since no blending occurs. We're kind of like overriding anyway, so we should still have some brightness stuff here. Yeah, and it's way better, as you can see. Let's do maybe 25 as the maximum. Yeah, so we have a small glow here, which I think is fine, because generally I didn't want it to be very very intense. Let's see the emissive pipeline here. Yeah, I want to fiddle around with yeah, we could actually stop sampling this by changing our emission color, and simply this could be one. Let's see. This could be one sample instead. Just write the emissive color into a transparent texture with the correct tint slash brightness. Yeah, so yeah. Okay, to do fix emissive pipeline stuff. We're sampling too much. Maybe add a way to do Or we could just expand the texture. An alternative texture, or expand the texture so that it has different layers. UV coordinates. Yeah, we could do that. So for instance, if we took this color palette here and this heat palette and kind of like added them alongside each other in the same texture, and then just, you know, exported the model with the correct texture, and then inside our emissive pipeline here, it would have knowledge that the last part of the UV coordinates would be the emissive part. Yeah, let's do that instead. Okay. Okay. So in GIMP, let's open this. Okay, image, canvas size. 32 times 32. Okay, let's resize it. Let's do zeros. Let's do 16, 16, 8 by 8, right? Okay, let's just do this as 16, 16. No, not 16 here. 8 by 8. No, 16 by 16. Okay. And let's open this. And copy that into a different layer. There we go. And let's fill it with this. And let's actually do something of the like. Okay. There we go. Whoops. Okay, so we have color. We have emission. And then we can have a heat layer. 16, or rather 16 by 16, or whoops, there we go. And then maybe a heat value here. Okay. And let's export this as a heat tower color palette. There we go. And let's save that. Okay. And inside our Blender thingy, let's do our model heat tower. And let's, instead of doing this, let's do the color palette here. And we need to fix the UVs, of course. Huh? Let's see. Oh yeah, it's because the UV mapping is off. Anyway, let's select these faces here. Whoops. Yeah, so we have that. Let's do UV editing here. Okay. And let's just see if I can actually shade it in a different way. Material, I guess, yeah, that's better for now, at least for selecting stuff. And let's do this. We also need this one, this part here. Let's do like this then. Oh, do I actually need to select under them as well? Maybe that's what's going wrong with some of the texture stuff. I don't know. Maybe I even want to do something like this instead and simply move all of it. Let's see. This is probably easier. And then let's do like this. And let's move that. Okay, let's do it all then. Select all, scale 0. Okay, and then it will have the same UV coordinates, and we can compress the file a bit. Okay, and then yeah, this is way faster. Give it a base color, then select whatever faces we need to manipulate. And then the last faces after this. That's the benefit of being the artist as well as the programmer. Whatever tools you make and shaders you make, you immediately know how to kind of like implement your changes. Okay, so we're back to this. Let's save that. Let's export it. Models, heat tower, and let's do this. Yeah. Great stuff. Let's clean out the stuff. I'm just waiting till I get annoyed enough with updating the files manually, or rather deleting the files manually. Okay. And of course we haven't updated our texture, so right now it looks kind of weird. So let's do that. Texture tools exporter. Let's do 3D models. Color palette here. Flip it. I'm pretty sure we don't need MIP maps for this. Let's save that as the heat tower.dds here. Okay. And we're back. Great stuff. Now our pipeline stuff here doesn't really. Let's just copy the files. Oh, we need to update the shaders as well. So right now we need to re-implement the emissive stuff here. Yeah, right now we don't get anything passed into that. But if we look into this, and let's see, let's do float 2 UVs equals these two plus and then just the diffuse. So this will sample the emissive part of the texture. Oh, okay. Let's see. This is actually wrong. Y here. There we go. Only the X component. Let's try updating that. and running it in RenderDoc. And as you can see, we do have the whole model though. And maybe that's, I mean, yeah, the brightness value is pretty low. We don't have any, yeah, we need to actually do the same thing as for the, we need to do the brightness check as well. But immediately we have a way better pipeline flow because we don't need to worry about binding several textures. I mean, we can immediately delete this heat tower emission texture and just load the heat tower, and we don't need to index inside the actual texture stuff. We just manipulate the UV coordinates. But anyway, let's do the brightness check. So the brightness is the diffuse albedo. And then if the brightness is let's do a float bloom brightness threshold. Yeah, maybe this should be part of the pass data. I mean, it's used in this one as well. Anyway, should be part of the pass data struct. Or rather, bloom brightness threshold, else return float for 0, 0, 0, a black color. Okay. And now our emissive pipeline here is way faster. And yeah, more meaningful at least. Okay. Oh, there's a problem here somewhere. Okay. Yeah, because we don't have any light interaction here. Yeah, we probably want to multiply this by 2, right? Or something. Well, the problem is now that So if we pass the transparency, let's do something like 2, double it. I guess could be part of the object data emissive factor. Yeah, but I mean, this is wrong, right? No matter what, it's wrong. Because, let's just comment this out. Because this should be transparent. Endpoint wrap. Do we want clamp here? Let's see. Yeah, I still think it's wrong. Yeah, it's not supposed to render the gray areas. Okay, let's see. Skybox, emission. Mesh. Maybe we don't. Well, maybe it doesn't register the transparency. Does it? Is that the problem? Oh well. Oh, it does. Is it minus? Is it because... let's see. Okay. So if I don't do this, Oh, I see why. Stupid error. I haven't updated the actual sampling. Oh my god. Stupid, stupid mistake. There we go. Okay, there we go. So this is now correct. Let's see. The bloom threshold stuff here will probably not be enough. Let's see. Probably won't be enough to, what do you call it? Let me just see. Let's see, scene brightness texture. Doesn't render anything because of the brightness check. Okay. Or should it be part of the material? I don't know. Or just the material? Yeah, that's probably better. So whenever we create a material here, we don't use this. So we create the diffuse albedo, we create the roughness. We could even collapse the diffuse albedo into something that only has 3 components. I'm not sure we want an alpha value on the material, but I don't know, maybe we do. Yeah. The material should hold an emissive factor. What's going on here? Now that looks funny. That looks pretty funny. I don't know why it flows over into the I guess it should. Oh yeah, okay. It's because I when I upload the material stuff, we actually end up doing some stupid stuff. Create material, create mate material. Let's see. Let's not use this. Okay. And we're back. So we have our emissive factor here. Yeah, so this is not needed anymore. This pipeline is already allowed to do whatever it wants. I almost proclaimed. And then we have our emissive texture here. Let's see how far it goes. 30, maybe 40. Yeah, okay. Then we need to add our bloom effect as the last part of whatever we're doing here. Uh, let's see, sampler state here. Sampler linear. Is it clamp? I think so. Assembler space 2, right? Isn't it? Uh, right now we can't use it, I think. Let me just check. Yeah, it's linear clamp you usually use. Do we have that created? Linear wrap. Linear clamp. 4, 4, 4, 4, 4. And we could do like this, and then the clamp. Okay. Just a sec, I need to find something I dropped. Whoops. Okay, there we go. So we have implemented our sampler here. Then we can use it. And I'm pretty sure when we're gonna sample the blur, or rather create the blur. Right now we will hard code a series of weights. Okay, so what's easier is to actually have a, I guess, a so yeah, how to do the actual blurring. Maybe we even want an intermediary texture that we write to. I'm not sure. Maybe we can combine them. Um, maybe we want some kind of other intermediary to be bound. Yeah, maybe we want a compute shader to do the actual bloom effect. Because right now we have the brightness values in a separate texture, and the idea is that we're going to blur them with a Gaussian blur on two directions, and then we actually combine them. Okay. So now just a sec. Yeah. Maybe we want to do it inside a compute shader. Maybe we want to do that. Let me just think about it. And look how other people do it. Some people do it with a pixel shader that they kind of like repeat. But Okay. Yeah, they generally seem to be advising against using a compute shader for it. Um, mm, yeah, okay. So I think we need to set up a bloom shader. Okay. I need a bathroom break. Be right back. All right. Yeah. So let's implement the bloom stuff then. Yeah. So what we will do is actually create let's do a render PostFX bloom passes, and let's do const unsigned int iterations. Also let's add a let's see, bloom pass. And we increase the amount of PostFX pipelines here. Okay. And let's do the actual call here inside. Inside this. Let's do one bloom pass. Okay, so we immediately call it. We just have to implement it, but first we need a PostFX thing here. Bloom passes. Let's just do bloom. A pixel shader. We don't need the application stuff right now. Okay. Let's see. Bloom passes. And we have bloom. Set name. Bloom parameters. And let's see here. I'm not sure we actually need this. Combined gamma, bloom and tone mapping buffer might not be needed. Yeah, so we initialize the PostFX thingy. And that's basically it. Everything should compile. At least I hope. Yeah, everything compiles and runs. Okay, and if we do all of this stuff here, except we do a bloom pass here. So we set our pipeline. We also do our draw command. Next, we need to think a little. Um, okay, so the idea is that we do some stuff to these pixels here. Yeah. Okay, let's do the first blur then. And I actually think we need a blur intermediary, but I'm not sure. So first we want to first time, maybe we should do this. Yeah. Um, take the brightness, texture, and blur it. Hmm. Do we need another render target view? Um, I don't know why some people. Maybe the. But we could. I guess you could store the brightness texture and keep it. Okay, let's just try doing it. Uh, 4 equals bloom blur buffer 1. 5 is equal bloom blur buffer 2. And we should still be fine, right? Oh no. So we do. Okay. So somewhere inside our render passes. This is fine. Blend pass extra is fine. PostFX. Yeah, this is should be fine. I guess. Oh, wait a minute. We have the bloom effect right running. That's why we're getting in trouble. It's not because of the textures. There we go. Yeah. So. Uh. So we could create two buffers here on the not on the emission pipeline, but on the bloom passes. I guess we could do that. SRVs. And we could basically just copy this code here. Bloom pass buffer 1 and bloom pass buffer 2. Right? I wonder how much memory we're using right now. 300 megs. Well, that's fine. Okay. uh, uh, I guess we need some parameters as well for the blur. But let's just try doing a pass number 1. So let's see, we have this structure here. Not this one. This is fine. Okay. first we need to take the there we go. So we take the resource and then we bind it as the texture that we sample, and it's let's see. Yeah, maybe we even don't need this bound. Yeah, but we could change this into something else. Anyway, and we transition out of the thing afterwards. All right, so we bind the texture here to the first slot of the bloom pixel shader. Yeah, this is the bloom one, right? Yeah. So this is for first pass. This is the one. Also, we need to set our stuff here. Should we clear it every time? No, I don't think so. Let's see. Let's set it to oh, did I actually create the custom RGB handle? Yeah, okay, I need to update these as well. So we have 1 and 2, 3, 4. Yeah, it's sad. It doesn't mirror the other stuff. Anyway, so it's one subtracted from the others. Custom get CPU handle. Yeah, so it would be 3. First bloom buffer. Okay. This needs to go down here. And as far as I remember, we don't write depth. Okay. So we bind the brightness texture, and we bind the, I mean, for blue. Yeah, this should be so. No. Let me see. Am I messing this up? Yeah, I'm 2, 3. So 1, 2, 2, 3, 3, 4 here. 4, 5. Yeah, so the first one is like that. So on RTV 4, on RTV 3, on RTV 2. Yeah, that's also what it says. Okay, so we want to grab the thing in the RTV and set it as a shader resource. We want to set our first bloom buffer, blur buffer, as our render target. We set the number 3 here to our descriptor table. It's now our input. Yeah, so this should write into a buffer, and let's reset the handle here. Back to our is it 2, 1? Yeah. Reset render target to our normal buffer. Right, let's see. Okay, we're rendering as we normally do. Let's do render doc here. And let's see, what did we call it? Blur or bloom. Pass buffer 1, it's white. And pass buffer 2 is black. So yeah, we succeeded. Okay. Uh, let's do a small yeah, right now we can't let's see. We will need to bind some weights. Let's start out by doing let's see. Let's do float weights 5, and let's do let's just create a buffer that is this big, even though we won't be using it just due to alignment. Let's do a series of float 2s, offsets. Okay. And we will be sampling this. Let's see. Let's do a float for color. Initialize as 0, and then let's just do 5 iterations here. And let's say that I is supposed to be less than this. And then we do color, add to the color. And let's do effect data constant buffer weights I times Render texture 1, sample with our sampler linear clamp with our, yeah, we actually need a vertex shader output here. Input. Whoops. That's not what I want. Input the UVs plus our effect data offsets I, that XY of course. So this will run twice. First for the horizontal, next for the yeah. So and we need to this should be okay. Let's see. Let's handle the what do we call it? Uh, the actual information here. Bloom parameters. Um, let's do struct bloom params. Let's do a float weights and float. No, DirectX float x and float 2 here. Offsets. There we go. Let's add some temporary bloom parameters here. Bloom params. Bloom params. Oh, this is supposed to be an array because we have both for both passes. Okay, bloom params. Weights. Let's see. I'm just borrowing these weights here from the what do you call it? OpenGL weight stuff. $16, and then zeros, 0. Huh? 1, 2, 3, 4, 5, 6, 7, 8. Well, let's do like this then. And then the rest of them should be okay. Then we need the offsets. And God knows how I'm gonna do them. Texture, 2D sample. Mm. Two-inch maybe. could also yeah, I'm not sure whether okay. Let's see. So the first offset is equal to 0, 0. But I'm unsure whether we should do anything. I mean, for the first part here, uh, huh? Oh, or what? Oh, there we go. So let's see. Let's see. Let me. Let's see. Okay. Okay. So I'm thinking that we can calculate the offset x less than or equal to 2. Nah. And inside that, int y equals -2. Y less than or equal to 2. Y plus plus. Let's see, unsigned index. And let's do index here. Is this not correct? Well, no. Yeah, our layout is not like that. Maybe I only want a 3x3 kernel. Uh, let's see how we fill this array here. Okay, we could do it like that. Uh, let's see, we also need a float. Let's see, texture, a delta divided by width, float, delta, this is U, this is V, divided by float, height here. So right now, if we would start at x minus 2, and then iterate over each y. So start at the minus 2, which should be the pixel above. The pixel above, then the next one, and then the next one, and then, okay, the pixel 2 pixels above, and then 1 pixel above, and the center, and then one below, and then one more below. And that would be the first 5 weights, or rather offsets. And then we would create the next one. And okay, yeah, okay. So we need to modify this to correspond to our, let's see, const expression here, kernel onsite, or yeah, onsite int kernel size. Okay, this is better. Yeah, the weights won't correspond to our pattern right now. So we will start at -1. Isn't it correct? Am I not? Am I messing up totally? No, let's increase this to 2. Okay, so let's fill that stupid array. So I imagine the first one is the horizontal pass, right? Well, then we only need to do this. If the horizontal pass is the first one, well, okay. This is kind of stupid then. We could fill it. We start out with the middle, and we sample on both sides. Maybe we don't want that many parameters. Well, it doesn't really matter, does it? Okay, let's do this another way then. Let's do it another way. Let's just do for unsigned int. No, yeah. I plus equals 2. So offsets. Let's see. Okay, so we set the offsets to this, then the oh well, the offsets should be double the size then. Actually, for us to be able to do this. Yeah, it should be the double size then. Let's do 16. Equals, let's see, x. Let's do x as a float, x times delta u. And let's do the next one. And let's do negative. Let's do this in debug mode and see what we end up with. Let's see. Okay. Let's see. Right now we don't do anything here. Okay. Hi, how are you doing? Okay, this bloom parameters. The first two, then these two. Perhaps even like this. Yeah, so starting out by being close to the center. And then actually number 9 there. Let's see, kernel size. And then let's do the same thing for the Y, right? No, let me just think. So this is correct, right? So if we inside the shader here. $16 or what? So the first two. Oh yeah, that doesn't make sense. Yeah, I don't want to do this. Right? First we sample from the center, then in the positive direction. So imagine this one going, well, we're gonna do const unsigned int kernel size. And this is disregarding the, no, let's just see here. And let's do times 2. Oh, -1 +1, I think. I'm not sure. Let's see, bloom, parameters, offsets, 0, 1, 2, 3, 4. Oh yeah, this doesn't help. Okay, so let's do 1 list and kernel size plus kernel size here. So we have a series of well, 1, 2, 3, 4, 5. And then the negative ones, well, minus this one. Okay. One, two, three, four, 5, 6, 7, 8, 9. So this is the horizontal pass, right? But what about... Yeah. Okay. So this is the horizontal pass thingy. Let's upload it. Upload service. Queue upload. Bloom params here. Oh, memory location, of course. Bloom params. Yeah, I think we do the upload queue anyway, whenever we're done. And this is supposed to be uh, okay, let's do the color is equal to and let's do this and this. There we go. Let's try doing that. And we of course need to bind the constant buffer. Bloom passes. Set graphics root constant buffer view. Let's do pp get view. No, virtual address. There we go. Let's try doing that and then updating our update our shaders here. Okay, let's see what's wrong. Oh, of course. Oh, wait a minute. Oh, there we go. There we go. Let's see what our Bloom stuff here gets done. bloom pass buffer 1. And this is black, and let's compare it to the scene brightness texture. Is it more blurry? Doesn't really seem like it, huh? Let's see. Bloom parameters, constant buffer. Let's do a float. Is it like this? 8. And then float 16. Let's do a struct test. Data 1. Data 2. Test data. Oh. Okay, so the first 5 values are our thingy here, right? And then this is 0, 0. Well then, yeah, okay. So 1, 2, 3, 4, 5, 6, 7, 8. 6, 7, 8, and then that seems about right. Oh, like this. Okay, so our data is actually correctly uploaded. But we don't get a blur, do we? I don't think so, at least. Hmm. It's definitely not blurred. I mean, Let's see. Aren't we doing this correctly? Constant buffer. We set the output as the oh. What? No, can't be. We set the render target to this one. Yeah, that's fine. And then we do draw instance, but do we need to clear it every time? I mean, oh yeah, because otherwise it would be the same from the previous one, right? Yeah. Yeah. Otherwise it would never get cleared. Let's do a bloom pass. Clear buffers first. Okay. Let's see. Handles 2. And then the second one. And let's do clear render target view. Let's just do a clear color here. Do I have to do it separately? I don't know. Maybe I do. And let's do this one. Okay. Bloom pass buffer 1. Yeah, before that it's cleared. And let's do a comparison to the brightness texture. Huh? I'm not sure. Oh, well. Oh, the weights need the modulo. Right. No. Wrapped over 4. So first we will have 1, then 2, then 3, then 4. Which will give us 0. That's not great. Uh, yeah, my overall structure here is not great. Um, we don't want 0. So if I set this to 0 and this to, and then +1, it shouldn't overflow at least. Why is it drawn like that? Oh, am I just zoomed in? Let's see. So this is the input. It doesn't really get blurred. So oh, are we in trouble here? It doesn't seem like the values are correct after all. Are we in trouble in terms of uploading the data? Does this change anything? Pipeline state. I mean, the first, no, they're not correct. This is like the last component, byte offset 16, float. Huh? Seems like this is not correct. Mm. It's a constant buffer. Should I write the whole buffer or what? Whenever I create a material, we upload to the material buffer. Yeah, shouldn't be that. And we actually bind the correct resource. Is it because of the alignment or what? I mean, this. Why is it mapped like that? Let's do float 8, float 2, 16. Nope, it doesn't get mapped correctly. So this kind of interpretation here is wrong, I guess. It's like, oh, it's actually arranging it in 16-byte intervals. Okay. Okay. I guess. At least so it seems. Yeah. So whenever it interprets that, huh? Let's see. Okay, HSL layout, memory. Okay, so the problem is that we're actually packing our weights. That's quite annoying. Yeah, so this doesn't get uploaded correctly, as you saw, and that's the problem we're trying to solve right now. So the packing itself is something that we want to handle. How to do it, how to do it, how to do it. Um, um, Let's see. Yeah, we need to rewrite the input layout here. We need something like float for weights. Let's do something like this, and then float for offsets 8. This is what we need since the packing is what we do here. So let's see. Instead we do still this, I guess, or what? Let's think about the loop afterwards. So can I do something like yeah, I can actually access that. Let's see, HLSL float for access index. Yeah, okay, we can allow that. So basically, we just do some computations. I think this will be fine, right? Because it should map directly. At least I hope. I need to delete the shaders and then render doc here. Resource inspector. Let's see, pipeline state down here. Pixel shader, bloom parameters. Yeah, so that should correspond to our, what do you call it? Yeah, so this, 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 and then this. Okay. Then our offsets. Yeah, we will bother with those afterwards, but we should have 2 pairs, 1 pair, 2 pair, 3, 4, 5, 6, 7, 8 pairs. That's not enough, I think. But yeah, maybe it's related to this. Bloom parameters, offsets. 1, 2, 3. What did we actually have here? Okay, so the second component is that one, then we have this one, then we have this one, then we have this one, and then we start on the negatives. Yeah. Oh yeah, okay. We need one more, I think. And then in here. No, that is that it? No. No, that's not it. That's not what we want. It's so this is large enough. We need to convert this back to 16. Okay, so let's see, let's try to update this. Let's see. Can I do? No, I can't. Okay. Okay, we will spend some more time computing the actual computations here. Oh man, this is so, what do you call it? Cumbersome. But we should be seeing something that is more. No? Or maybe it is correct, since we actually sample it down. Okay. So should we just try to cast it then? Yeah. Okay, let's see. So we do something like static const float 2 offsets 16. I can't do that. Oh. Okay. Let's do that instead. We can't get around the packing. Let's see. And float 8 G weights. There we go. Let's see if it compiles and runs. It does. Okay, so let's do that instead. G weights 0. G offsets 0. And then this should be fine, right? Okay. And let's see. Update the shaders. I really need to create that script. Yeah, I'm gonna fix it. I'm gonna fix it. Okay, let's see. Well, uh, let's compare this to the original. Huh. Let's see. Okay, maybe the first pass is like this. Maybe there's no problem here. The problem is though. Let's see. This needs to be -1, +1, and this needs to be like this. Right. Because the first time this will be 1. Huh. Do we just want to be doing like this and then what will happen if we do like this? Oh, I want the weights to be actually, yeah, I want to skip the first one. That's why. Yeah, that's it. Okay, then we need to do the vertical pass as well. Let's see, let's fix that build script. Xcopy, overwrite, new. Let's see. So let's just check inside the PostFX Bloom. So this should be overridden. Yeah, it does. Okay, it automatically overrides. I don't need to do anything. Whoops. Okay. Let's see. So okay. Then okay, so we do that one. Let's upload our what do you call it? Let's see. Okay. Horizontal. And let's do vertical. And we swap this. So we have DTV times, and it will be Y instead. So it's obvious what we do. Let's do this the other way around. Float Y times this. Whoops. and then minus this. Yeah. Okay. And let's do, let's see. This is getting cumbersome anyway. First pass. Now, let's just make this on one line and then let's see. Let's see. So this is setting back to our. Let's see. So set back May 2nd RTV for normal pipeline back into required state. S render target and texture into required state. Now set back normal render target and the no. Well, I think this is wrong, right? No, this is correct. And this is also correct. Yeah. No problem. It's all correct. Nothing to see here. Okay. Then we want to, this is the horizontal. Let's do vertical. I actually think I'll move this down here because it's part of the horizontal pass. Okay. Let's do RTV handle second bloom buffer. And let's see, let's set this plus size of bloom, params. I think this will be correct. I'm not sure. We need to transition this into a render target then. Yeah. I think it's the first one, wait. And let's then yeah, we transition that, and then are we allowed to do that? Yeah, it's 4, right? Yeah, this actually binds the render target. So 4 is the first one. Yeah, so the first buffer here, which was our render target, will now be our resource. And let's set our render target. Let's do it in the same order. We set the render target handle, we set the constant buffer, we bind the render target. Maybe we should do this before, actually. I think so. It makes more sense. Yeah, we bind it, then we update the resources here. And then we do a draw call. I'm not sure about this one. But let's see what happens. We will probably get some errors. Yeah. Okay. Yeah, we need to do that then. Okay. Up here, we can't do like this. Let's see, utils. Let's see, size t, constant buffer size. There we go. And instead we do plus. Okay, we got rid of one of the errors. And of course the resource state. Yeah. So we need to transition it. As expected. Did we? Yeah. So we transitioned that into a shader resource. And after this, we swap it back to a render target. Okay. And we don't have any errors. Okay. So let's see what we end up with. Let's see, and let's do this one, and then, yeah, I don't think that we actually, let's see, it's not really blurring, is it? Is it? Maybe it is. Yeah, maybe it seems like it. Yeah, this is clean cut, and this is actually a bit blurred. Okay. Okay. Yeah, we do wait on the GPU a bit. Okay. So we have a blur pass, at least one. Okay. Okay. Let's try using that for now. So let me just take a screenshot before we try implementing the blur thing. Or rather the bloom effect. It's not really that elegant, right? But we would probably want to do more passes. It's a lot of pixel shading, and yeah, I'm not sure whether you'd want to kind of like close and execute in between. Because right now we record all of our command lists, and then we kind of like execute and wait. But maybe we don't need to do that. Maybe we can feed the GPU better. I'm pretty sure it will be kind of like starting, stopping, starting, stopping instead of actually doing something. If we monitor it, let me see. Task manager. Let me see performance, GPU. Okay, so if yeah, it basically uses almost nothing of the GPU, 14% or something. So we could definitely optimize optimize on that. Anyway, let's see. Well, we don't know. Yeah. Let's just implement a third one. Right now we simply do this stuff here over and over. Okay. Okay, so inside our renderer here, let's do 3 instead. And let's we of course need the thing there, but instead of this we will do like this. And I think it's the second buffer that needs to be reset. Yeah, and then what did we actually bind it to? So bloom buffer 2 is actually 5 here. Let's see. Okay. We're having trouble. Execution error. Huh? Uh, null pointer specified. Let's see. So pipes. Sorry, we should be set. This should be set. So let's debug this. So when do I actually get into trouble? Null pointer passed. No. That shouldn't be the case. Okay. Let's see. One. Oh, it's because it's the Bloom Pass pipeline. Of course, yeah. Of course, yeah. So let's just attach this. All right. So it was right all along. There we go. And okay. Mm, there we go. We don't even get it. One single error. Okay, that's pretty great. Okay, so the second thing should be bound to a shader resource, and inside our combined here, this should be, let's see, our second texture here should be our bloom. And then we do the HDR color. Let's do a bloom color. Let's do the point clamp as well. Yeah. HDR color plus equals bloom color. And let's see. Okay, and let's compare that to our old value here. It's definitely not much of an effect. Oh, no, no. I just thought that let's try with a low exposure value. Maybe a higher exposure level. Well, I can't really see much of a difference. So this is it without bloom, and this is it with bloom. Yeah, it's definitely brighter. It's definitely brighter. Okay, and this without the bloom. Yeah, I guess. So without bloom. Whoops. Without bloom. With bloom. Yeah, it's definitely more kind of like shiny, glowy. Well, I'm not sure it's much of an effect. Yeah, it's definitely not much of an effect. But at least we actually did the bloom. Let's see. Let's see. Let's do when we do iterations here. Let's do 3 iterations. Maybe 4. Okay, then we do a I list and iterations. I plus plus, right? So then the first time we get to the horizontal call. Let's do SRV index. Okay. So this is the opaque one. Well, so buffer 1, it goes from being a render target to a pixel shader resource, and then it goes back to a render target. Yeah, and this starts out as a render target, gets into a pixel shader resource, and gets no. Yeah, okay, that's the other one. And then this gets set as a render target, and then it gets swapped back again to a resource afterwards. Okay, so let's set the Yeah, we bind the second one as a render target. So let's bind the first bloom buffer as our render target here. We do that. We set our constant buffer. We set, well, this one should differ. So 4 should be it, right? No, 5 here, because it's actually this one we're using. Okay. So we set the render target. We bind the resources. We do the draw call. And then we transition this from a render target into a shader resource. And this from a shader resource into a render target. And then we set our second bloom buffer as the render target. And then we end the call, of course, with this, because, yeah. And this should just be copyable. And this should be like this, right? And we don't need this right now. I think so. Maybe. Okay, we got a lot of errors. And of course I need to well, let's see. This one. Isn't this? Yeah, that's the fix. Huh? It looks kind of weird. Let's look into it. And it's definitely expensive to do it without actually utilizing the GPU. Okay, so okay, I don't draw anything to it. Well, that's wrong, right? Skybox. What seems to be the problem, Mr. Officer? PostFX. Pipe. Set name. Combine. Gamma. Bloom. Tone map. Post. PostFX. PSO. Bloom. Pass. PostFX. Okay. Let's see. Uh, okay, so Skybox Bloom passed. Okay. We clear them. Okay, we set the render target here, bloom pass buffer, and we okay. We do a more should I merge them? Okay. Bloom pass buffer 2. Should I perhaps... Oh, maybe it's because... Let me see. Yeah, definitely we're just kind of like scaling it all down, right? Or is... Oh, the values might be so small that they're kind of like getting removed. Okay, maybe the problem is the original brightness texture. Let's try actually just really going nuts with the emission thing here. Let's do 50. And let's copy over the buffers. So whenever we do okay, let's see. So the first one, inputs and outputs. It definitely looks more blurry, this value here. Then I don't know, didn't it? Yeah, it does get additional blurring here, but it's not very big. Yeah, the values get so absurdly small. We definitely end up with something that is more blurry. But it's black eventually. Okay. Maybe it's because this one actually contains our... Okay, let's try swapping the PostFX sampling here. Did this change anything? I think it's... Okay, let's see. I mean... I really can't... Let's do 500 then, just for testing. And let's see. Inputs, pass buffer to pass buffer 1. The values are so extremely low. The values are so extremely low. I mean, if this if this bloom didn't get rounded off, it's like, oh my god. Is it the weights? Is it the sampling? Is it something? I mean, the brightness thingy here should be pretty high. Let's do 550 maybe. Yeah, even 50 is fine. So we're around 300 or something. Something stupid like that. So let's see. So this is on the X. And this is on the Y, so that works. I guess the weights themselves are kind of like maybe fucked. Let me see the bloom shader. We should be adding this. Hello, how are you doing? So the first time. There's no shader graph? What do you mean? No shader graph? What are you talking about? Let's see, so should I just try increasing the what do you call it, weights? We will do this temporarily. Okay, then the bloom effect is way too much. Let's see. Const float factor. So it's related to the why do I end up with a green component? Now this looks pretty weird. Yeah, and the colors seem a bit off, don't they? It's like the rounding itself is like ending up eating most of it. I mean, this is better. There's a noticeable blur. Yeah, we end up waiting for almost 1 millisecond on the GPU, so I should batch this. Definitely batch it. But now we do have some kind of bloom effect. Let's see, let's add back the lighting. Okay, this is definitely a lot more glow-like, right? And should we play around with the... Oh, we double the exposure as well. There we go. Maybe we want a bit less of an exposure, yeah. That looks decent, I think. So this is with bloom. And let's wait before we disable that. And this is just without the bloom, so it definitely looks way better. with the bloom effect here. Yeah, it's definitely glowing. And if we even reduce the exposure a bit more, yeah, the color correction is starting to kind of like do its thing. What happens if we turn off the gamma? Well, the gamma gets way too high. That looks pretty great. Okay. 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 Let's see. Maybe I want a bit more on the blur effect here. Now I created it in Blender. Okay, let's see. Let's then create some kind of like functions, execute present. Let's see, reset. So what we would want is some kind of like close the command list, execute, and then we begin recording a new command list. Yeah, so basically we begin recording a new command list. So we need functionality for that. So in between our calls here, we would kind of like, especially during our maybe after our opaque call, we do a submission, and then we do a submission of our PostFX thingy. Yeah, but we need to look into the actual scheduling in order to do that. Right now, our stats here seem to be telling us that we're mostly during a frame waiting for the GPU. That's almost all of the frame time. But the GPU is not working very hard, as you might see here. It's only at 18%. So the whole wait thing is something. Let's see. Execute. Commands. So during so we would want something like do this, execute it, and we probably can't do that before before we what do you call it? We can't do that while it's in flight. So we need some kind of synchronization. Yeah, so let's see, command list, reset commands, static void, close command list. There we go. And let's do maybe 4 command lists. And also, let's see. Yeah, we will deal with this static pattern right now. But current list index. Let's see. Let's see. Yeah, right now we will hard code by 4. So we increase that. Let's see. Static void reset all command lists. Then for unsigned int I. Yeah, we should just do a definition instead of doing this. So define command list command gxe d12 dx12 command lists for and let's change this and this. And I think we should be able to still do. No, that's not it. This instead, right? Everything will still work, I think. No. Oh well, it's not not actually set yet. So I I I I I I. Yeah. Uh, yeah. Well, and this is usually 0. But this shouldn't really be problematic, since maybe it's because of the non-close flag. Yeah, I think so. Did we actually succeed? We succeeded. We didn't throw. Yeah, command list open. Yeah, so that's it. So if we just do like this, we won't get any errors. Yeah. So we can always change the and this should actually not take a value anymore. Get command list. Should just take this. Static. And we're still good, right? Where are we in trouble? Static. Let's see. Static void close all command lists. Let's do the same thing as here. Close. Should be fine. And then if we do this instead, when we actually execute %, we do DX12 command list manager, close all command lists. And we're not having any errors anymore, so we close all of our command lists before we present. Yeah, so if we do a call here, dx command list manager, instead of, let's do close current command list instead. Let's see. We could return the closed index. maybe a uint32 here. Let's do unsigned const unsigned int current index and return current index. So we get back the close current command list and get index of old one. Reset commands. Yeah, that's fine, I guess. Maybe we actually do want a const unsigned int index. Okay, so we can actually grab an graphics list now. So if I do something like this dx command list manager close current command list. Let's see, const unsigned int index. Let's just do a uint32t here. And then we do the index pass here. Oh, const unsigned int index. Maybe uint32t, just to be concise. Index whoops, this is fine, right? Huh? Is it just slow in terms of updating? Oh, it can actually be 0, right? Well, I guess we could do, yeah, it doesn't matter, right? If we simply disable this, because no, okay, let's just call it different things then. Get current yeah, we should update that, and then kind of like disregard this and update all the errors here. Nah, let's just revert it back. I'm not gonna bother updating all of it, so this will be the actually current name. It's bad. Actually gets the current command list. And let's do by index. Right? No? Huh? Why are we in trouble? Where did we go? Did we mess something up? Uh, is this the problem? Did we mess up somewhere? Yeah, apparently we did, but where? Undeclared identifier. Let's see. What did we do? Let's do. Maybe it actually used to be. Okay, inside here. Well, I'm not using that right now, so it shouldn't be a problem. What about in our scheduling, right? No. Yeah, and it's probably because it can overlap as well. So if we do a bool here by index here, yeah, maybe the type is not known unsigned int, then doesn't really matter. Yeah, it's probably that. Unsigned int doesn't know how to collapse it. Unsigned int. Yeah. So that's the problem. Okay. Let's see. By index. There we go. So if we do this, unsigned int, by index. So this should close it, then this should send it to execution. So if I do something like after a render pass here, let's see, maybe DX12 renderer execute commands. If I do that, what will happen? Okay. Oh, we need to bind the heaps then. Prepare frame, begin frame. Descriptor heaps. Yeah, so set descriptor heap. And there we go, and then we simply just call set descriptor heap here. Okay, and inside renderer, execute commands, DX12 renderer, set the script to heap. Do we need anything else? Okay. Okay, so, and then we do maybe this. Okay, so far so good. We end up kind of like doing stuff here. Okay. Okay, let's see. Whenever we encounter the error, let's do this. Okay. Okay, so can't be called on a closed command list. Okay. Can we get the state actually? Can I check? Check if command list is closed. Directx12. Okay, let's create a different version of close all used command lists. Let's do that instead. And let's implement it. Okay. Because right now when we close current command list, we close it and we increase the current list index. There we go. Let's try doing that instead. Yeah, now we don't have that error. Okay, we have another error. And when we do this, we set this to 0. All right, now. Wait a minute. Okay, so this closes everything. Reset all command lists. This should set it instead. Okay, right now we're not rendering anything. Also, we're definitely waiting a lot. Maybe we want to execute that. Maybe not clear buffers. Yeah, definitely not clear buffers. Void set buffers. Yeah, so this is more like it, right? Let's see, set buffers. So this definitely doesn't help us. If I move it up here, yeah, I don't really gain anything. Maybe we didn't see a performance increase, even though a small one. I don't know. Yeah, we do a lot of less waiting now, I guess. Less waiting now. So we have some calls. Let's see. Let's profile the whole thing. So right now we have the ability to actually do this. But let's see what's the actual thing that is costing us. Render pass. Um, yeah. I hope that it would give us more performance, but it didn't. Let's see. Do we have an upload or... Oh, we do have it during the year. Never mind. We have it down here. Execute, percent, wait. Let's see. Single execute. Let's you do the. Let's do backend DX12 backend. We don't need the draw anymore. Oh, there we go. And let's do a GUI pass, skybox pass, shadow pass. Let's see, this is the bloom pass. PostFX HDR combine. Let's do render pass. And let's see what's tanking our frames here. So we use 42 seconds on our thing. So we're basically waiting for the GPU. Huh. Yeah, so the bloom pass is not that big of a deal. Our render pass here actually ends up being huh. Yeah, we would almost be back to our old FPS if we limited the whole wait for the GPU thingy. Let's see. Okay. So yeah, we need to figure out how to do that. It's happening down here when we actually wait for the current fence value. Hmm. So let's see. So we try to execute. Let's see. Let's do NVIDIA Advanced API command to command buffers. Yeah. Let's see. Uh, so let's see, synchronization. Mm. Okay. So let's see. Try to aim for 5 to 10 execute command. List calls per frame with sufficient. Uh, so maybe it's the resetting. Okay. Okay, so maybe we need to work with our execute stuff here. So we need to call execute to start the work. What's NVIDIA GPU view? Okay. Okay. Let's do let's do this. And let's try following it. What's the GPU view directory? Directory. Let's say C program files. Let's do that. Nah, we're fine. Let's do it. Let's see log.cmd. Okay, let's see. Let's run the application then. Okay. Okay. That's pretty cool. Uh, uh, okay, I definitely need to be able to what do you call it? Yeah, different stuff. Okay, I don't know what's happening when we're actually uh, what do you call it? Streaming. So we need to let's see. GPU view. Let's see. Let's see. Let's see. Let's see that. Let's see, graphics. I don't know. Can I zoom or something? Charts. I need some. I don't know. Can I zoom? Uh, okay. Set. I can't zoom out. Okay. Seems like there's a lot of idle time. And the pattern seems somewhat similar. Okay. Yeah, I should definitely try disabling the oh, this is the decode. Seems like it's consistently overlapping. Yeah. All right. But I've been going at it for a very long time. I'm gonna end the stream here. Yeah, I'll definitely be looking into how to performance optimize. We got a lot of stuff added, and yeah, as you can see, we're kind of like waiting for the GPU forever, uh, which takes up most of our time. So yeah, I need to figure out a different scheduling system. Um, yeah, maybe even do some multi-threading. Mm, yeah, but I definitely need to figure out the scheduling itself. Anyway, I hope you found it helpful, inspirational, entertaining, or something of the like. We implemented Bloom, we implemented gamma correction, we implemented regular tone mapping, and yeah, I think we made good progress. So yeah, if you found it helpful, entertaining, inspirational, or something else, please consider supporting the channel by subscribing, commenting, or liking, or even checking out ways to support me in the description. All right. Please take care, everyone, and hopefully I'll see you around.